Welcome to another video on my Raspberry Pi 1 Model B+, connected to network interface, serial cable and a band cable for GPIO, general purpose input output. Also connected to a raspicam, Raspberry Pi camera, which is supported by a fischertechnik stand. It runs Raspberry Linux, and I will show you shortly. Then the band cable is connected to breadboard with, excuse me for shaking the camera, is connected to breadboard with electronics, and in this case I want to focus on this one. And if you have watched my previous videos, then you know that it was already a subject to a whole series of videos which I concluded. This one is also focused on that series, but in a slightly different way, because I know the software works and all the elements work. So what's new? Well, it is again focused on Python right now. It will be also focused on, in a later stadium, C++ or C, either of them, but also on communication. So with that perspective and that said, let's see for software. So the software, what is it about? Well, actually this is something that you may be familiar with if you've watched my previous videos. It is this, although right now it's not showing anything because this is the breadboard, so I'll take it away. It was just for testing, because if you've seen my previous Raspberry Pi 1 videos, this is a very different setup. The former version did not do anything anymore. It didn't update. So I tried to upgrade, which led to absolutely nothing. So I just reinstalled everything and didn't change anything with the software. However, I have come to the conclusion after some tests that it doesn't work anymore. Nothing changed, but it doesn't do anything. As you can see here, no module named RaspberryPi. And yes, this is capital, here small print. Doesn't matter. It just doesn't do anything anymore. So but about communication, and yes, SPI dev, I don't know, time, I don't know yet, because it hangs on this one, but I took the opportunity to include serial, pySerial, and here I already have put some stuff on it. Setting the port to the TTY USB 1, since that is the serial port to which the Pi is connected through Minicom, and let me name this Minicom. Baud rate, speed, and open it. It doesn't do anything more yet, will come. Then Octave, mathematical and scientific programming language. Loading instrument control, clearing every previous output, setting it to the same speed and read anything that comes through the serial port and putting it on screen immediately. Will that work? After this is being programmed, yes. Then this one, obviously for this circuit and not for the other ones. So where am I at? Well, actually this. So I can safely save this one, run it. No, that's the wrong one. I now have to use this one. Not that it matters, but this is the better one. And if you see here, everything is still there, the same way as it used to be before the upgrade. So whatever is going wrong, I'll have to find out again. Which also means that after a really major upgrade, things thoroughly have to be tested. Serial have to be tested thoroughly. Minicom, yes. A few VNC desktops. This is one. I can use one on a tablet. I can use one on another computer like my MacBook that you can see in other videos of mine. As yet, no use because this isn't working yet. So let's try to debug, and well, not really debug because I know this code should be working, but what is it then? And after some careful looking, RaspberryPi not solved by the way, but I realized that for this program I don't even need RaspberryPi. If I look here, I see two LEDs, which were originally intended for pulse modulation, very separate from this whole other circuit, and that is used it. So right here I have now disabled everything that is used for the LED for RaspberryPi. In the meantime, a small test revealed that I was using the wrong port for the serial interface. TTY USB 1 is used on the laptop side, not on the Pi side. On the Pi side it is in this case AMA 0. This should be used. So now it will run. Not that it does anything, but it should be running and giving input and output. But then what about the serial interface? Well, that is quite clear. I can here send something right, and then say okay, I should be able to do it like this, and then have something written to it, and that should be visible in here. No, it should not. Is that true? I am using SSH in here. No, Minicom, so that would be possible to do something. Let's see how this works out. So I will, this is saved, I will run it. Let me see again how I should run it. Well, F5, pressing F5 will run it. And now I should actually get a result here somehow. It is in the same configuration. This doesn't work apparently. I'm not getting any result. Leave minicom. Okay. Will it do now anything? It should do anything. Except that I have to replace this one. So exit and start. Now it's reading from the correct port. It's still not doing anything. Okay, let's start again. Nothing yet. Minicom again. It should be writing SPI. Okay. Back to drawing board then. Right, something's kind of solved. I was using a wrong baud rate because I used the wrong command here, which is also shown right here, that it actually does work. SPI is shown twice because it's going twice through the loop. That works. Here it still doesn't work in Octave. The only downside is that when I reopened the channel after closing this one, I didn't get it anymore. So also I didn't get share the whole system, and if I go back, let's see if no, I can't get it back anymore. It said that it was wrong baud rate, but it did work in the Python shell. So let's see if this is working still. No, still not. And here you get SPI. So that is very good. Now the nice question is, although I get here all zeros, can I get it to write the value? So SPI, that would be nice. And then it would be nice to have here write byte SPI2. Oh, and with a semicolon I get this value right behind this one. So I do it like this. Not quite sure, because SPI2 is a byte. SPI like this would be more bytes, but we'll see how that ends up. That would be a nice experiment then. And here of course a semicolon then. So let's see how this one works out. It's not iterable. So I would have to do it like this. Semicolon. There. Right. byte is, and then that one. Let's see if that works out. Line 33. Oh, that is actually this one. It doesn't want to write this one, really. Then I need to find out how it can write an actual value, because this is byte, which is the whole word, but the rest it doesn't do. Curiously. Another thing is, of course, how can I do it like this? Okay, how can I do it within Octave? Oh, by the way, it does do it. Look here. Alright, let's do that. Wait. Can I get it the third time? Yeah, most definitely. It just puts it through. So that works. Okay, let's quit here. Run it here. Go. Nothing at all. Oh wait, yeah. Let's limit this to 3. That's a good one. Go. And go. Yeah, right. Oh, beautiful. I was waiting for a lot more characters than I had to. So if I change this now to 1, go, and I say go. Oh, isn't this beautiful? Except for the zeros in between, because I don't like that one. But for the rest, no complaints. Oh wait, yeah. If I change this to 2, what's the result then? And go. Okay, so I have to do 4. I have to do actually 4 now, and soon 5. Yeah, okay, nice. So the serial communication does work. Just this one I want to have, and that is something that I have to find in the manual. Right, I have tried to find a method to get a number sent over the line. However, serial write uses a byte, and an integer is not a byte. So if I want to get numbers like this and the C value, etc. over the line, I would fail. What I could do, and I tried to use the struct package and then pack to convert integer into a byte. Unfortunately, I get this error. So I have to give up on that one for now. And in order to get something over the line anyway, I will comment this out. and we'll see what I can do here. Where is the I2 coming from? That is, oh, SPI2. Alright. SPI object is not iterable in line somewhere. Alright. I think line 39, which is exactly here. Right. Here I can't do it either. I have to comment it out. For now. So here we go again. The only thing is now that it is once only and it is not in the while loop. So it is not repeated. That's the only downside to this writing. And anything other, yeah, I can write it here of course, but it, let's say right next to print, so write byte, and then say same thing. Right here. This would be in the while. So let's go. And you get LDR value. Now I don't like the way this looks. So let me open Minicom USB again. Oh, this has clearly the wrong baud rate. And this goes. Right, no new line. I can do that of course, but so far okay. And with that one I say end of this episode of a new series. And that's it for now. No C or C++ yet, that's certainly coming. But for now, serial communication is clearly possible within Octave, although I do not really like the way it is presented. But I hope I can change that. And Minicom is showing the way it is. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, very much appreciated. You can also follow me via Instagram and Twitter. Please show your support by making a donation via either PayPal or Wired. And you can also become a patron and have your name mentioned as a supporter. All information, including URL of my website, with lots of pictures, etc. and more information under this video. So please, this is to be continued. Have a nice day and bye bye.